Welcome to Bedtime Astronomy. Explore the wonders of the cosmos with our soothing Bedtime Astronomy podcast. Each episode offers a gentle journey through the stars, planets, and beyond, perfect for unwinding after a long day. Let's travel through the mysteries of the universe as you drift off into a peaceful slumber under the night sky. Galactic Gastronomy. The evolution of space food. In the early days of space exploration, the idea of astronauts eating meals in the zero-gravity environment of space was both a fascinating challenge and a critical necessity. Space food has come a long way since the 1960s, evolving from simple, nutrient-dense pastes squeezed from tubes to gourmet meals enjoyed by astronauts on the International Space Station, ISS. This narrative takes you on a journey through the history, development, and future of space food, highlighting the ingenuity and dedication required to ensure that astronauts remain nourished and healthy while exploring the cosmos. In the late 1950s and early 1960s, as the United States and the Soviet Union raced to put humans into space, scientists and engineers faced a multitude of challenges. One of these was ensuring that astronauts could eat and digest food in the microgravity environment of space. Early space food needed to be compact, lightweight, and shelf-stable, capable of withstanding the rigors of space travel. The first American to eat in space was John Glenn during his historic Mercury Atlas 6 mission in 1962. Glenn's meals were simple: pureed beef and vegetables in aluminum tubes and a sugar cookie cube. The food was not particularly appetizing, but it provided the necessary nutrients to keep him energized during his brief mission. Glenn's successful consumption of food in space demonstrated that eating and digesting in zero gravity was possible, paving the way for longer missions and more sophisticated food options. As space missions grew more ambitious, so did the need for a wider variety of foods. NASA and its partners began developing freeze-dried and dehydrated foods, which were lightweight and had a long shelf life. These foods could be rehydrated with water available on the spacecraft, providing astronauts with a more palatable dining experience. By the time of the Apollo missions in the late 1960s and early 1970s, astronauts were enjoying a more diverse menu, including shrimp cocktail, chicken stew, and even brownies. The Skylab missions in the 1970s marked a significant advancement in space food technology. Skylab, the first American space station, was equipped with a galley where astronauts could prepare and heat their meals. This allowed for more variety and better tasting food. Skylab astronauts had access to over 70 different types of food and beverages, including canned and thermostabilized meals, which were heat-treated to destroy bacteria and enzymes that could cause spoilage. The ability to heat meals significantly improved the quality and enjoyment of space food, making it more similar to what astronauts were used to eating on Earth. The end of the Cold War and the beginning of international collaboration in space exploration brought new challenges and opportunities for space food development. The International Space Station, which has been continuously occupied since 2000, serves as a laboratory for testing new food technologies and practices. With contributions from space agencies around the world, the ISS has become a melting pot of culinary innovation. One of the primary challenges of space food on the ISS is the need for a balanced diet that meets the nutritional needs of astronauts. In the microgravity environment of space, bone density and muscle mass can decrease, and the immune system can be compromised. To combat these issues, space food must provide adequate calories, vitamins, and minerals. Nutritionists and food scientists work closely with astronauts to ensure that their diet is both nutritious and enjoyable. Space food on the ISS comes in various forms, including freeze-dried, thermostabilized, and irradiated meals. Freeze-dried foods are lightweight and retain their nutritional value, while thermostabilized foods are heat-treated to kill bacteria and extend shelf life. Irradiated foods are treated with ionizing radiation to eliminate pathogens and parasites, ensuring food safety. These methods allow for a wide variety of meals, including international dishes like Russian borscht, Japanese miso soup, and Italian pasta. In addition to pre-packaged meals, astronauts on the ISS have access to fresh produce delivered on resupply missions. These fresh foods, such as apples, oranges, and carrots, provide essential vitamins and minerals and offer a welcome break from the monotony of pre-packaged meals. However, fresh produce has a limited shelf life and must be consumed quickly. One of the most significant advancements in space food technology has been the development of the Space Food Systems Laboratory at NASA's Johnson Space Center. This state-of-the-art facility is dedicated to researching and developing new food products and technologies for space missions. Scientists at the lab work on improving the taste, texture, and nutritional content of space food, as well as developing new packaging materials and methods to extend shelf life and reduce waste. The Space Food Systems Laboratory also collaborates with international partners and commercial companies to develop innovative solutions for future space missions. One exciting area of research is the development of closed-loop life support systems, which recycle waste products into food and other essential resources. These systems could be critical for long-duration missions to Mars and beyond, where resupply missions from Earth would be impractical. In recent years, there has been a growing interest in growing food in space. The veggie experiment on the ISS has demonstrated that it is possible to grow fresh vegetables, such as lettuce and radishes, in the microgravity environment of space. These experiments are crucial for understanding how plants grow and develop in space, as well as for developing the technologies needed to support long-duration missions. Growing food in space presents several challenges, including providing adequate light, water, and nutrients, as well as dealing with the effects of microgravity on plant growth. However, the benefits of fresh, homegrown produce are significant. Fresh vegetables not only provide essential nutrients but also improve the psychological well-being of astronauts, offering a sense of connection to Earth and a welcome diversion from pre-packaged meals. Looking to the future, space agencies and private companies are exploring new ways to produce and deliver food for space missions. One promising area of research is 3D printing technology, which could allow astronauts to create customized meals on demand. NASA has already tested a 3D food printer that can produce pizza, complete with layers of dough, sauce, and cheese. This technology could revolutionize space food, providing astronauts with a greater variety of meals and reducing the need for bulky, prepackaged food supplies. Another exciting development is the potential use of lab-grown meat, also known as cultured meat, for space missions. Lab-grown meat is produced by cultivating animal cells in a controlled environment, eliminating the need for traditional livestock farming. This technology could provide astronauts with a sustainable source of protein, while also addressing concerns about the environmental impact of meat production on Earth. As humanity prepares for future missions to Mars and beyond, the challenges of space food will become even more complex. A mission to Mars, for example, could last for several years, requiring astronauts to be self-sufficient in terms of food production. Developing sustainable and reliable food systems will be critical for the success of these missions. One potential solution is the concept of a space greenhouse, which would allow astronauts to grow a variety of crops on Mars. A space greenhouse would need to provide a controlled environment with adequate light, temperature, and humidity, as well as protection from the harsh conditions on the Martian surface. Researchers are already studying the feasibility of growing crops on Mars, using simulated Martian soil and other conditions. In addition to traditional crops, scientists are also exploring the potential of growing algae and other microorganisms as a source of food for space missions. Algae are highly nutritious and can be grown in a variety of conditions, making them a promising candidate for space food production. They can also be used in closed-loop life support systems, helping to recycle waste products and produce oxygen. From the early days of simple tube foods to the sophisticated meals enjoyed by astronauts on the ISS, space food has come a long way. The challenges of providing nutritious, enjoyable, and sustainable food for astronauts will continue to drive innovation and research in the years to come. As we look to the future of space exploration, the development of space food will play a crucial role in enabling humans to live and work in space for extended periods. The technologies and solutions developed for space missions could also have significant benefits for life on Earth, from improving food production and sustainability to addressing global food security challenges. In conclusion, the narrative of space food is a fascinating journey through the history and future of human space exploration. It highlights the incredible challenges and achievements of scientists, engineers, and astronauts as they work to ensure that humanity can thrive in the harsh environment of space. From the humble beginnings of tube food to the cutting-edge technologies of 3D printing and lab-grown meat, space food continues to evolve and inspire, offering a glimpse into the future of human exploration and the possibilities that lie beyond our planet.